the Oracle RAC architecture hasn't really changed from a hardware perspective over the last years. We still require, going from bottom to top, we still require shared storage, ideally connected through a SAN switch. We still require servers which are all connected to the shared storage, and these servers need to be connected via an interconnect, and this interconnect needs to run over a switch. Over the last couple of years, we have changed our attitude towards what a dedicated switch would mean. We can have things that are shared as long as they're isolated, and there are more and more white papers that we're going to write about it. And if you go to oracle.com, go to RAC, you will see the latest updates there, or go to cluster layer. And then if you continue the stack up front, here are 4 nodes. We still have requirements to have a public LAN, and through the public LAN you will connect to your RAC cluster. If we look into what software we deploy on this hardware stack, again, here the 11G Release 2 perspective, it hasn't changed ever since 10G much either. Now, with 11G Release 2, we have changed it a little bit. So, what we have done here is, with 11G Release 2, we have introduced Oracle Grid Infrastructure. Oracle Grid Infrastructure combines formerly independent Oracle Clusterware and Oracle Automatic Storage Management in a home. So if you deploy Oracle Grid Infrastructure, you get both of these components and you can use them with Oracle RAC. As Oracle Clusterware ever since 10G Release 2 has been a requirement to run an Oracle Real Application Cluster, you will have to install Grid Infrastructure every time you want to run a RAC database. Now, as I mentioned in my presentation on Wednesday, we kind of make Oracle Grid Infrastructure more and more a infrastructure software that you can use for other purposes, for example, for failing over other applications. But again, we'll not focus on this topic in this presentation today. And guess what? This architecture fundamentally is not changing for Oracle 12c RAC. As you may have noticed, the subtitle has changed, and I'm showing you now the architecture for Oracle 12c RAC. And nothing has changed. And as I mentioned on Wednesday, this is part of the idea we have with 12c RAC. Take a stack that has matured over more than one release and make it more useful, improve it in subtle things, which we are going to talk about a little bit in the course of this presentation. If you further drill down the stack, and I've taken away a few notes, what you get with each layer is here outlined. On the Oracle Grid Infrastructure level, what we provide you with is a node membership layer based on top of the OS. So we are running on top of the OS in user mode with the node membership. We also provide you, as part of Grid Infrastructure, more precisely as part of Oracle Clusterware, an HA framework that you can use to fail over, make your applications highly available. In addition, as part of Grid Infrastructure, you get the ASM instances because we combine ASM and Oracle Clusterware in the Grid Infrastructure. And then if you look what Oracle RAC provides, it actually provides the Oracle database instances, which then constitute what most of the people refer to as RAC. The RAC layer itself, however, is really the layer in the database. What you look at here is more what I would refer to the RAC stack. Yes, the RAC stack. Now, if you look into what happens in the storage, if you use Oracle ASM to manage your storage as part of shared storage management, you will put all your database-related files and clusterware-related files into ASM. Now, the latter, the clusterware-related files, we have put into ASM only ever since 11G Release 2. Formerly, those would reside in either a cluster file system or raw devices. With 11G Release 2, which I'm showing here, and with 12c, therefore, you will put your Oracle Clusterware files, or you should put your Oracle Clusterware files ideally into an ASM list. This applies to the voting list and the cluster registry. And of course, all your database files will still go, ideally, into Oracle ASM, so control files, data files, local Oracle files, and so forth. What has changed, and again, I'm already talking about the 12c layout here, what has changed is what we have done on top. And you may want to notice the 12c edition here, which is deviated from last year's. We have provided you with an Oracle Cloud file system, also known as ASM Cluster File System, ever since 11G Release 2. And we have enhanced the functionality or the capabilities of this file system throughout the releases 11.2.2, 11.2.3. So with 11.2.3, for example, we added the capability supportedly to put backup sets onto an ACFS file system, which we hadn't done before. However, with 12c, we go a step further. With 12c, we allow you to put your data files in a supported way onto ACFS. Formerly, you could have done it, but we said it's probably not what you should do. There may be performance issues. With 12c, you can put your data files onto an ACFS file system once it's available. This is one of the enhancements we have done in this area. If you then drill down further and look at the resources Oracle Clusterware and the grid infrastructure provides or come with, there were some changes. And what I'm showing here is the layout on 11.203. So if you install a grid infrastructure 11.203, by default, every time I pass by here, something is speaking. Maybe I shouldn't do that. Sorry for that. If you install an 11.203 grid infrastructure, you get these resources deployed by default. And if you look at the most left node, for example, I'll walk you through them. However, the big categorization here is local and cluster resources. Local resources are resources that run on every node in the cluster. And if this node is not running, so they have a firm or fixed assignment in some cases, if this node is not running, these resources will not be started on another node. Some of them may be, but I'll come to this later. So local and cluster resources are basically grouped by what runs on a node, and if that node doesn't run, then it doesn't run. It's a local resource, and a cluster resource is a resource that can float in the cluster. So if a node runs, if it runs on a certain node and this node goes away, it will continue to run on another node because we will fade it all over automatically. Just to give you an idea, the listener, and especially the scan listener is a cluster resource. And as you may know, if you install grid infrastructure, you install scan, you get a scan listener and you get a scan IP. These are cluster resources. They will be running on one node, but if that node goes away, they will be running on another. So is actually the node width. The node width, however, is a same-line thing, the one that I wanted to mention before. Because actually it runs on every node in the cluster. However, if this node goes down, the node width is one that will fade over to another node. So it's, somewhere in between, but technically as it floats, it is a cluster resource. And then we come to the resources that run locally or will not fail over. First and foremost, the Oracle ASM instances. Because in 11GLEs2, every node runs an Oracle ASM instance as soon as you either put your Clusterware files into ASM, or you use a disk group, or you create a disk group. Because we need the Oracle ASM instances running if you want to use ASM for whatever purpose. And if you put data into this group using ASM, with 11.203, former version also 11G, release 2, you also get an Aura disk group, and then disk group name, disk group resource, which is to say, you can create a dependency of a database to disk group. And why would you do that? Well, because you need the data in this disk group to start the database. This is why we have this resource, so thereby we can model dependencies between them. What you will also find on a per node basis is a listener. Every node has a listener, and this is a so-called node listener. And ideally, you would have only one of them. I'll come to this later, but this is the default. One listener per node, in addition to the scan listeners that are floating. We have the Oracle notification server, Aura.ons, which is a notification server we use for FAN, and I will come to this briefly later on. And we also have the Aura CVU, Cluster Verification Utility, which is somewhat new, especially the fact that it will run periodically in the cluster, starting with 11GLEs2. With 11GLEs 202, we have already had it, but with 11GLEs 203, showing here, we have actually made it a continuously run resource, so it will run every 10 minutes, it will gather data about your cluster, and it will put it in a log file. Why would we do this? Because we have had customers saying that there is a chance that my cluster will change over lifetime, but CVU was recommended to run only pre-installation or manually as required. By us running CPU all the time, as in every so and so many minutes, and putting the data aside for you to read later, we make sure that if there is a change to the cluster, you have a way to detect it. What you will also find is the Aura Net1 network, which is a network resource we have introduced with 11 Release 2, and its main purpose is to monitor the physical network connectivity on the server. Last but not least, we have the Aura registry for ACFS. So if you use ACFS file systems, you can manage them and register them in the cluster registry so that it would start up and be mounted automatically on startup of the cluster. Of course, if you deploy databases in this cluster, there will be additional resources, namely, for example, Aura.dba name DB resource or services, if you deploy dynamic services on top of your databases. And if you want to go home and check all this, crasctl stat for status rest-like resource -t would be the command that you run. Some of you may have noticed that I forgot one little resource here, which is the GSD. Now, I didn't quite forget it. It's a very special one. Aura GSD is actually a a local resource, as you can see from the blue background. However, it's typically offline. It will not go online until you do it explicitly. And why would we do this? Well, the GSD used to be global service daemon, used to be a daemon that we used 99 times to manage a cluster. Unless you have a 99 cluster on this 11.2 Release 2 grid infrastructure, you wouldn't need that thing. So who runs a 99 cluster on 11.2 grid infrastructure? Exactly. No one. So that's why it's offline. Question is, why is it still there? Well, because officially it is supported, so we have to have it, just in case one of you had raised his hand. Now, if you look at the same thing for 12c, it hasn't changed so much, if you had noticed, and that's again by design. By default, the resources that you deploy will be the same. However, default here is to say, if you choose a very simple installation flow, if you deviate and use, for example, Flex ASM, which I've introduced on Wednesday, I will come to it in a minute, then this may change. But by default, you can run it as it was, with one exception. You see the GSD daemon? It shouldn't be there anymore, because we will not support it in 12c anymore. So that said, what changes if you introduce a new component that we made available, or we will make available, with 12c called Flex ASM? Now, for those of you who have seen the Wednesday presentation, who has seen the Wednesday presentation, please? Oh, the majority, but it's approved. So I'll briefly walk you through it. Flex ASM describes a new way of configuring ASM. The main two benefits we get from it is a reduced overhead per node, and also a higher availability of the database instances, because we can now fail over. I'll make it more clear. If you enable Flex ASM either during installation of the grid infrastructure or as a post-install script, those is possible, then what we will do is we will not have an ASM instance running on each node in the cluster as we used to with 11.2, but we will have a default number of 3 ASM instances running in the cluster, assuming you have 3 or more nodes. That said, if you have 2 nodes, you will get 2 ASM instances. If you have 3 nodes, you get 3. If you have 4, 5, 6, 7, 8, 9, 10 nodes, you still get 3. Now, you can change the number of ASM instances that are floating in the cluster, but the default will be 3, and I will come to that in a minute again. The other thing is, if you now haven't got an ASM instance running on each node in the cluster, the question for those of you who are working on 11G or previous releases arises, well, how can my databases run? Well, very simple, because in 12c databases can actually connect to what we call a non-local, if you want to call it a node, fine, but I would call it a non-local ASM instance in the same cluster. So on a node where there isn't an ASM instance, or where an ASM instance has failed, or was purposely shut down for maintenance, the database instances will be able to connect to a non-local ASM instance by themselves. Well, that is 12c or later databases. 11G release databases cannot make use of this failover capability as soon as an ASM instance fails, because they expect an ASM instance to run on a node. If you want to combine both of them, 11.2 and 12c databases, you will be able to do this, but it will require a certain configuration in the cluster, which we will then document when 12c becomes available. Now, that said, you can actually conclude what's going to change as far as resources are concerned in the grid infrastructure. And that's why I said in the beginning, I'll try to make you understand what impact it has so you can conclude it yourself rather than looking at it on the slide. If we make ASM a floatable entity, so if we make the ASM instances float around the cluster and run on any node if you want to say so, then they obviously become a cluster resource, and therefore they are here in the green box. Remember before we had the green box as cluster resources, the blue one's local, so that's changing. We have a few other resources that I will mention briefly, but let me show you. So the ASM resource itself, the Aura ASM resource, becomes a cluster resource, but we will also replace a local resource, a local Aura ASM resource, by an Aura proxy ASM resource. And that's a proxy, it's not very heavy, so the reduced overhead is still intact. It's just a proxy that we have. We also have more emphasis on you deploying GNS, so that's why we will probably get a GNS when you enable Flex ASM for reasons I will not elaborate on today. And we will also get an I/O server, which I cannot explain due to time today, but the ASM part may have covered. Now, last but not least, and it's not highlighted in bold, but on top of the blue box you see also that there is an ASM net listener. And that kind of makes sense, right? Because if you now have your database instances connect to an ASM instance remotely, most likely we will use components in the stack that we already have. How do clients connect to database instances? Well, via the listener. Now, the database instance is a client to the ISM instance, so it connects through it via a listener. Of course, all these resources are highly available. Now, when I introduced this slide on Wednesday, I had quite a few people coming around to my demo booth, kindly enough though, asking, well, is it a really good idea to put ASM only on some nodes in the cluster? What happens to my I/O? So maybe I want to make that clear right quickly. A database does not require an ASM instance for the direct I/O to disk. Instead, an ASM instance can be envisioned as a volume driver or a volume management driver. And all it does is it maintains extent maps that the database instances need to know where to write the data to. So when a database instance starts up, it asks the ASM instance to tell him the current extent map, and then for any subsequent I/O from the database to disk, unless it extends storage, it would require ASM. It would just write to the data file because it knows where it resides on disk by meaning of the extent map. Now, if your database just issues enough data, so like inserts, for example, and you find the need to either extend your table space or to extend your table space, and therefore your data files, then the ASM instance is contacted again because the extent map needs to be modified. But for an insert within a prefixed table space or therefore data file, you don't have to always reread the extent map, and for this I/O, the ASM instance is really required. That way, having an ASM instance on every node in the cluster was indeed an overhead, which we could get rid of, and in addition, we got the high availability, because now, if an ASM instance goes away from a server, and you may have even more than one database instance on that server, it wouldn't impact the database instances. So that way, it's a very efficient way of running Oracle ASM, and that's why it's called Oracle Flex ASM. That basically concludes the architectural changes. We have a few more regarding VIPs and networks, and I want to go through them right quickly. Just again, a brief summary. The major changes in 11 GLEs 2 were the introduction of scan VIPs, and also the dependencies of scan VIPs or node VIPs on the network resource. And then again remains in 12C. All VIPs on the public network, scan node VIPs, or if you wish to create them application user VIPs, will still depend on the network resource. So the dependencies are outlined here in the picture, and again, this was part of last year's presentation that you will find online. The network resource has the main purpose of physically monitoring the network interfaces on the server. So we issue an RACInternals command to see whether the server has still a network interface that's up and running. And this is a big improvement because before 11G Release 2 we have used the default gateway ping. And that had caused some issues. And some of you have worked around those issues using RACGVIP, and some of you have still tried to do it in 11G Release 2 and failed. And that's because the RACGVIP is only there in 11G Release 2 for backward compatibility. Changing it has virtually no effect. So if you have a problem with the I/O, with the pinging of the network interfaces, and you see that Oracle Grid Infrastructure reports a network interface to be down, it is either an issue with IOCTL or with the default gateway ping, because we do fall back to the default gateway ping. But the IOCTL check is the first one, and we have seen on occasion issues, and we are hopeful that in 11.2.03 they have been fixed. Just a few details about the node VIPs. Again, that's available on the net already because I'm talking about 11.2.2. However, again, the principles remain in 12c. So if you want to see the configuration of any Oracle resource, even though we don't encourage to modify them, you can check them in the RACTL status res aura.rac1 or any node name here, .vip. It will be your node name, of course. And the -p will give you access to the profile, and it will tell you that the resource name that we are looking up here is the Oracle RACware VIP. But what I'm really pointing out to is the VIPs in 11G Release 2 are actually monitored by an Aura agent. So that way they are fixed. You can't modify it. It's a fixed check that we run. Part of this run I already explained. What we have also done in 11.2 Release 2, or 11.2 or 2 for that matter, we have increased the check interval. And the check interval is kind of aligned with the network interval, or a network resource check interval. So in former releases, before 11.2, we had a check interval for the VIP of about, I think, 10 minutes or something like that. And maybe a minute later, but we couldn't go lower because checking a resource requires CPU. And pre-11.2, we couldn't really run too many checks a minute because that would have required too much CPU. We changed enormous things in 11.2, which had led us to decrease the time, so we can check more frequently, more efficiently. That was one of the major changes in 11.2. And we have created the start and stop dependencies on the network resource, as I mentioned before. And all this actually remains. If you want to look into it, you can do it, especially in 11.2.02, where we have made a command available that you actually can actively work on the network. So SIDCTL config network, for example, or modify network. In 11.2.01, we didn't have this explicit command, but quite frankly, not so many are using it in this context. Anyone here who uses 11.2.01 grid infrastructure? Good, that's one. Or he didn't dare to raise his hand, he or she, but that's all right. So if you then want to say, okay, my default network is the one that I have provided to grid infrastructure on default installation, that's what you get. However, we have a lot of customers who wish to use more than one network, and remember please, a network represents one subnet. So if you want your cluster to operate within more than one subnet from a public accessibility point of view, then you need to add another network resource to the cluster post-installation, because during installation you could have defined only one, maybe twice, but go for one and make this a post-installation step is my recommendation. So you install your cluster with one public network, maybe 192, 168, whatever, and then later you say, well, I need one, this is routable, 141, 142, and so forth. Then you add another network, and you provide it with another network number, as I have shown it here in my example, and you create another network on the public network. That means now your cluster is theoretically accessible via VIPs in a different subnet. However, we still need to generate these VIPs. So we create a network first, and on top of the network, which represents a logical subnet, so to speak, you put your VIPs. And I've shown you the example here, and again, you will find this online, and I'll make it short here. One difference I want to point out to you, if you create a VIP, as I've shown it in the previous example, it will create a node VIP. And node VIPs have been invented to make database connections. You can use them if you want to connect to something else in a database in the cluster. However, they have a very specific failover behavior, which is probably not the one that you want for your application if you manage it in a cluster. A node VIP, as a local resource, as I described it, will, the semi-resource actually, a node VIP will preferably run on the node it was created for, and it will fail over either on network failure on this node or on node failure on this node. And once this node comes back up, it will fail back. And this is the default behavior which you shouldn't be changing because it's an Oracle resource. However, this behavior may not be suitable if you want that VIP to be used for connectivity to your application. Because your application should probably fail over to one node, but it may or may not fail back on returning of the original node. So that way, if you want to provide an application VIP which has this slightly different behavior, you want to use the app VIP CFG command, application VIP configuration, and create the VIP with this command. Just a minor difference here. And this VIP will have a different default behavior, which in addition you can modify because it will not be an Oracle resource, it will be just a resource name such as my VIP, and therefore you can easily modify it with RACIntl, though it can be used for database-related configurations if you need to. Now, if you had noticed in one of these commands, I actually highlighted the idea of creating VIPs, and I can show it to you one more time, it was over here. Here. As you can see, I can create a network that accepts a VIP or a subnet range which is provided by DHCP. Why would you want to do this? Because if you have just enough production clusters in your environment, such as mine here, where I have 4 production clusters in my data center, if you install them, you have now to provide 4 times by 4 VIPs for the node VIPs, the scan VIPs, and you have to give it a number, and then you have to put it into your DNS. Ideally, you could think about, well, why can't I provide DHCP addresses for those IPs, as I would do it with my laptop, and then have someone else figure out the name resolution. Using dynamic networks is a great idea if you have enough clusters in your data center. And this is what we can enable you to do, and we have a service, the grid naming service, which will then make this dynamic IP assignment resolve dynamically to names. The grid naming service was actually an 11.2 feature. Who has heard about the grid naming service with 11.2? That's quite a few, and then I have to run a second test. Who uses it? Alright. Exactly what we found. Now, 2 reasons why we found it. Some customers said, well, it's a great feature, except you have to have one grid naming service for each cluster that you provide. Not so efficient. Secondly, dynamic IPs meant DHCP or DHCP all the time. Not so many customers wanted to set up an additional DHCP server or configure the one that they had. With 12c, what we have done is we have provided the ability to use a shared GNS. The shared GNS can either be put on a separate cluster as shown here, or on one of the production clusters. However, it will take care of all the clusters in the data center. And secondly, the introduction of IPv6-based IP addresses make DHCP for that purpose somewhat redundant or obsolete if you want. Because you don't need to have a DHCP server anymore to get IPv6 IPs generated. You can use stateless auto configuration. Now, those of you who have paid closer attention, they would say, yeah, but hang on a second. RAC isn't yet available with IPv6 IP addresses. Well, 11.2 is not. We have IPv6 support in 12c for public connectivity. I'll come to this after this section again. This section is about listeners and scan. I've explained to you how you can model your public network, how you can model your VIPs. As we all know, that isn't giving you any good to connect to a database. You need listeners, and in 11.2, the major enhancement was that you needed to use, or wanted you to use, a scan listener. Now let's focus on the normal listeners and the so-called local listeners first, or the node listeners. You have three types of listeners in 11G release 2. Listeners that run per default on every node of the cluster. The node listeners or local listeners that I mentioned before that are represented by the Aura listener resource, which is a local resource. That's why it's in the blue area, the Aura listener resource. Then these listeners by default are managed by Oracle cluster layer or the grid infrastructure if you want to think about it this way. And then we have introduced the scan listeners. And we use that. All these listeners depend on VIPs. The scan listeners depend on scan VIPs. The local listeners depend on the VIPs per node. And again, this doesn't change in 12c. But there are a few changes which I'm going to mention later. Let's look at the listeners one more time. You configure listeners these days by default when you install grid infrastructure. Now, the one thing that happens then is that this listener will by default run as the user that installed the grid infrastructure, which may not be the Oracle user. That can impose a problem because if the local listener runs, as the user grid, this is a listener that will establish the foreground process against the database. Then all of a sudden, your foreground process will be opened by a grid user. Possible, but maybe not so great. That way, you can actually change the owner of the default listener that we deploy and set it to the software owner of the database, as I've shown here. Now, this is very important because I get all these questions saying, oh, I want to create local listeners per database. And I don't understand why. Because in 11G, we have had the idea you will connect through scan, and then scan will connect you to the local listeners, which you can modify as you modify any other listener. Why do we need a listener per database? Well, I have an answer, which I got from some customers that said, well, because I want to have them run separate networks. That's fine. I'll show you later how that works. Because it's very simple. The listener we create with grid infrastructure is still a listener. So anything that you can do with the listener, you can do with the one that we create during grid infrastructure installation. Such as, you can define another port. Sure, by default we will create it using 1521, but if you wanted to be listening on 1525 or 34 or something else, that's fine. You can define another owner, as I have just told you. If you don't want the grid user to own this listener or open processes for this matter, that's fine. Can you define another host? Yes, you can. Actually, we allow you to create listeners out of the database homes that you are deploying subsequently, but we wouldn't really say we should. Can you add another listener to another port? Absolutely. And if you want to do this, this is a slide that I've shown, and there's a mega link node out there, 106.357.1.1, which explains to you in detail how to configure a second listener on a separate network in 11G release 2. So that is to say, if you have these multiple network ideas, which is fine to access your cluster and multiple networks, this is the node you want to read to create your listeners accordingly. But one thing I really need you to remember, it's just a listener. We have had a lot of questions whether you can configure additional listener parameters, and some of you said, well, if I do this, it's changed by the Aura agent subsequently restarting a listener, for example. No, it's not necessarily the case. It depends where you change it. I've given you an example here where I created a listener called just a listener, and this listener, if it's managed by Oracle infrastructure, has two files now. It has the endpoints and it has a listener file. Now the endpoint files is the one that the agent maintains and will reset if so required. However, if you just want to change certain listener parameters, such as introducing a rate limit to rate limit the connectivity to a local listener, you can do it. You do it in the listener.aura of this default node listener, which I call just a listener, and it will persist across the restart. It's just the place where you need to do it is the grid infrastructure home, not the database home, because I assumed this listener would be running out of the grid infrastructure home, which is somewhat required. And you can see my rate limit didn't change even though I restarted. I guess we can, go away from the default listeners. Another listener that we introduced is scan. And as I said last year, I'll say it again. I haven't seen a feature which is in general very simple, that was so much discussed and explained, and examples were provided as the scan. When we introduced it, it caused a rush of material and questions, and I understand why, but it's amazing. If you go and Google scan Oracle, you get so many hits. But if you look at it on high level, it's very, very simple. It's another listener, and all this listener does, and we have 3 of them, but that's not so important. From one listener perspective, all this listener does is it receives incoming connection requests. The database instances in the cluster have registered with this listener in addition to the local listener. The scan listener will distribute the request to the least loaded node if you have enabled load balancing, and then the local listener on the node will make the eventual connectivity to the database instance. That way you can think about a scan listener as a router, dispatcher, but dispatcher is not to be mixed up then with the dispatchers we have in the database otherwise. And I'm not going to talk about scan again because of there were more presentations about it. There's a scan paper out there on oracle.com. Go to RAC, and there's also a good metering code out there, 887522.1, which gives you a lot of information. The 3 things I want to mention is that you have 3 scans per default for HA and load balancing. And I get the question still, 3 years after we released it, whether we can have more or less scan listeners and therefore scan VIPs in the cluster. And the answer to this is yes, you can. The way we create them, the scan listeners and the scan IPs, is we read out either your host file or your DNS. And if this host file and DNS has just enough IPs, you get respectively so many. The default should be 3, and that's what we assume. If you give us 2, we will have only 2. Now, if you have a 2-node cluster, third IP is not giving you much because one scan IP and grid listener would be running on the same node. That way, it's modelable, but 3 is a good number. The other question that I get, how can we see what configuration I use? And there is server control config scan, which will give you information. And again, the white paper that I pointed to before will talk about it more detail. What I really want to come to is the red line here at the bottom of this slide. In 11G release 2, we had the scan only serve one subnet at a time because it depended only on one network at a time. In 12C, that obviously changes. I'm skipping this slide. And this is summarized in the scan FAQ. So, can you define another port for scan? Yes, you can. It runs per default on 1521. You can change it to another one, and the MOS node 220970 will explain you more. Can you define another owner? No, you can't. This is the only one thing that deviates a scan listener from another listener, the local or node listener, because we want this listener to be managed by grid infrastructure, and we don't want you to change the owner. The owner is the grid infrastructure owner. Shouldn't make a huge difference for you because, remember, the listener that makes a connectivity to the database is not a scan. Can you define another home? No. A scan listener runs from the grid infrastructure home. You cannot move it to a database. Can you have more than one node listener with scan? Absolutely. You can have multiple node listeners and only one scan. And in 11.2, that was actually the default, and there was no more than one scan on the system. Can the scan and the node listener port differ? Absolutely they can. And again, all these things are actually well summarized in the metallic node 972501. However, If you had the case where you had multiple subnets or networks in your cluster, there are additional things you have to consider, and this listener networks is one of them, as much as the documentation or the Meterlink node 106.57.1. And these recommendations derive from the fact that in 11 GLEs 2 you could have only one scan per subnet. So if you had multiple subnets, you needed to explain to scan that certain clients cannot be routed to VIPs coming from the other subnet. That's what it is all about. Well, and we need to explain to you that in multiple ways, although you have asked one simple question. Why can't we just have a scan per subnet? Well, it took us only one release to get there. In 12C, what we have done is we have introduced, as I mentioned before, the supportability for IPv6 based IP addresses. So nowadays you can have your clients, so that is when 12C is out, nowadays you can have your clients connect either using IPv4 or IPv6 based IP addresses. As part of this, we have enhanced scan that now you can have multiple scans per subnet. But please note, this is kind of independent. You have a subnet which is 142.168. This subnet number that I just gave you, if you extend it to a full IP, is an IPv4 format. The scan will operate so that if you have an IPv4 format, you will automatically get an IPv6 VIP. And these two IPv4 and 6 IP formats, the scan will serve. If you have a second subnet, you get a second scan serving again two representations of the same IP. That's how we do it. And that brings us to something very important, which is client connectivity. How does the client connect to the scan listener? And last year I talked about it, and I made four fundamental distinctions, but they are subsequent. The first distinction is the client, as such an application, can either directly or indirectly connect to the database. What do I mean by this? A direct connectivity to the database would be SQL+, here represented by this computer, and you go directly to a service. The follower is VIP port service, or you can connect via a connection pool. In this way, your client is indirect because the application uses a connection pool. The connection pool is the entity connected to the database directly. However, no matter whether you do the one or the other, the connectivity issues that you have to consider are four. Well, actually, two connectivity issues and two load balancing issues. At the moment you try to connect, you need to think about connect time load balancing and connect time connection failure. What that means is very simple. Your client connects, it goes to the scan, one of the three scans, and the scan is then going to go and connect your client to one of my three servers here if you want to connect to the email service, because the email service is the one that is available on all of the three nodes, thereby saying on all of the three instances that I use. The production service, however, is only available on two, and the batch service is only available on one. So if a client, either direct or indirect, wants to connect to the email service, the scan will decide whether it will go to one of the three nodes down here. Now, if this node is available, that will be fine. So then nothing happens. So then the scan only has to choose one of the three, and we are good to connect time load balancing. However, if one of the three nodes is not available, then you fall into connect time connection failover, because the client needs to fail over somewhere else. And all of our clients, no matter what you do, in 11 GLEs 2 timeframes of 11.2 clients can do this. This is actually not a problem. The other two aspects are runtime related. Runtime connection load balancing and runtime connection failover. What if you made a connection and now you want to reshuffle this connection, either because there's capacity issues or because you need to because something failed? This is more complicated. However, I will not only focus on the connection failover and connection failover areas today due to time. The other things are discussed in the Understanding RACInternals from last year. Because in the area of connection failover, either at runtime, either at connect time or at runtime, we have made substantial enhancements in 12C. Now, just to briefly walk you through, it actually happened in 11 times. You either connected via JDBC thin or using a TNS names connector string, and then you would provide the scan name, my scan in my example here, and then a port, and then the service. What we call this connect string that you see in the upper box JDBC is the easy connect. If you use a full-blown TNS connect string, you would put my scan as a host, port as 1521, and then you would define the service. Both of these entries will connect you to the email service on one of the nodes in the cluster. As I said, runtime connection failover would then say, well, what happens if I had a connection and my server fails, as indicated here? So we assume the client had a connection and now the server fails. Well, then something is going to fail over my connection. And that's something we need to discuss. Now, if you have connectivity problems in the first place, the two major nodes 975.457 and 13069.271, again available in last year's version, will help you. What I'm really coming to is, what if the client was disconnected due to failure of a node? What can we do to the client? And last year I said there are really only two ways of helping your client to recover from this failure. Number two will actually protect in-flight transactions, but I'm going to talk to them right quickly anyway. The first one is transparent application failover. Who has heard about that? Of course. Transparent application failover has been available since 8 times. And it depends on the TCP/IP stack to report a failure. So if the node goes away or the IP goes away, it will react. And it tries to make the client unaware of the failure. It provides means of time connection failover and runtime connection failover, but it does this only so that the session would fail over to another node. And it allows for pure selects to continue, given some assumption hold true, but write transactions will never be recovered. The alternative solution has been ever since 10G, FAN. FAN has exactly an opposite approach. It will notify your client proactively, so it doesn't rely on TCP/IP. It will notify the client if something fails in the cluster, and it will expect the clients to do something about reconnectivity. FAN therefore is very suitable for indirect clients that connect through a connection pool. Because if your client is a connection pool, a FAN event can inform the connection pool that it should invalidate data, it should invalidate physical connections to the server, and it should not reconnect a logical connection to a physical that just failed. So if you use FAN and you have connection pools and indirect clients, the ideal solution. However, if a transaction was still in flight, even though the connection pool did all the reconfiguration as far as connections are concerned, in-flight transaction would have still failed until 12C. Before 12C, and I have this slide in the Wednesday presentation, before 12C, what could have happened was that an instance failed and the application would return an error to the end user because the in-flight transaction might have succeeded, but there was an interruption that the application couldn't handle. So thereby, RAC would have helped to continue database operation, but not the application. It would have interrupted application flow and the user app would receive an error. That can lead to all sorts of things. Multiple orders, accidental orders, wrong transactions. You order a pair of socks, you get a pair of stockings. Which is okay for some people, not so much for me. Also, if you have covered the part where we have a way to protect the application from unplanned downtime, we would have solved the problem for planned downtime, because what we have received as feedback from our customer was, RAC is great for planned downtime, however, there's still a lot of preparation that you need to do, right? You need to throttle down your transactions, you need to make sure that services are relocated so new transactions won't come in. With application continuity in 12C RAC, we have solved this problem for unplanned downtime, because now what we can do based on a JDBC thin driver in the first place, or on a universal connection pool, or if you use WebLogic service, WebLogic server, what we now can do is we can give you a layer that sits between the application JDBC driver and the database instance. And if the database instance fails, what the Oracle 12c database with Oracle RAC can do, it can preserve commit outcome and ensure application continuity. And as I said on Wednesday, this is Tech Talk 4. You can continue, or more precisely replay, an in-flight transaction. So that way we can provide success to the end user for unplanned and planned downtime. Because if I cover the unplanned case, it doesn't matter whether I purposely stop an instance, it's still covered. So that way, using application continuity, you can perform maintenance operations at any time. Now that said, it requires you to use a 12c JDBC driver and databases. How it works, right click, because we're running a bit late in time. The application sends a request now through the new driver. This new driver enhances the call by state information against the instance. Should the instance fail, the fan will inform the driver, which acts as the direct client, to the database, and the client will replay the failed transaction in flight. That works transparently for well-behaved applications, and I can't go into all the details, but there was a great presentation, I think yesterday morning, and there will be more information available as 12c progresses. And then you report a success, of course, to the end user. I really need to hurry up here. Let's talk about node membership right quick. Node membership hasn't really changed over the years. It has actually been the same, and we have always used the CSSD to provide node membership and monitor the nodes in the cluster. What we did in 12, in 11 GLEs 2, we replaced the OPROC daemon with the CSSD monitor. But those are really the only two changes that we introduced. We monitor your nodes on two communication channels. One is a network heartbeat, one is a voting disk-based communication, which we also call the disk heartbeat. And as I have talked about this all last year and in other places, I'll make that clear. Now, if the network heartbeat fails, what you will see is one of the nodes will be evicted. So if a ping doesn't respond within 30 seconds, we determine that a node is not working anymore. We'll put a poison tag, and we will additionally put a ping on the voting disk. But if the ping on the network doesn't work, eventually a node has to go. Same thing for the voting disk. We ping on the voting disk, and if a node doesn't respond, the ping from the voting disk, within 200 seconds by default, we would evict a node in the cluster. Regarding the voting disk ping, please remember we have a majority rule, so you always have to have at least 2 voting disks available to each node in the cluster. If you lose more than the majority, so you have 3 voting disks and you lose 2 of them, all the cluster nodes will go down. And the other change that we did in 11 GLEs 2 was we put the voting disks into ASN. And I still get a lot of questions about it, and last year's presentation will go into detail. However, the change, we do not change how we use the voting disks just because they're relying on Oracle ASN. We'll just manage them differently. But again, the majority rule and other things that you have seen before still persist. I'll skip these slides so that you get the 12c information. They are all available on the network. You Google them. What we did with 11.202, however, was that we changed how we fence nodes. Before, in 10.2 and 11.1, if we fence a node, that always meant we reboot the node forcefully. With 11.202, we have introduced a feature that's called rebootless node fencing. And what that feature does is it tries to restart the cluster, but not reboot the node. Because when we reboot the cluster only, then applications like the ones on the top right and left, application X and Y, that aren't managed in the cluster wouldn't be affected. They would still run on the node because we don't reboot the node. So that way, with 11.202, we should see actually less reboots. Let's walk through an example again. If you lose network connectivity, as I mentioned before, we had always rebooted the node formally. With 11.202, what we try to do is we detect that the network heartbeat failed, and we will stop we determine that it doesn't respond anymore in 30 seconds, we will stop I/O processes first. Because the main reason why we fence is to protect split brain, as you have seen in one of the slides that I briefly walked through. So the first thing that you want to make sure, if you cannot have the nodes cooperate with each other anymore, you want to prevent them from writing data that is shared, because if they write uncontrolled, they can corrupt the data. So that's why we fence, that's a good thing. But if we don't do it by shutting down the node, the first thing we need to do is, if we encounter this problem, that we need to restart the stack. So I/O processes goes down first. If that is successful, and we'll check it multiple times, we'll continue to stop the cluster stack on the node which we think should leave the cluster, to the degree that only OHASD will remain running on the node, and OHASD will remain in a way that will automatically restart the cluster stack on the node that we have determined to leave. That way, the node never rebooted application-wide, never changed state, but all the database-related information, all the applications that run in the cluster have been successfully protected. And then we start the database again. Again, there are exceptions. If you cannot stop the I/O processes successfully, we will reboot. If the CSSD gets killed in the course of this process, we still reboot. So we are very careful to make sure the clusterware stack can be restarted so that nothing remains and everything will be restarted from fresh and the node perfectly joins the cluster. If we can't ensure this, we will reboot the node, and again this will be available. In this context, on Wednesday I spoke, or John McHugh spoke about the flex cluster. And the flex cluster could be thought about as a logical enhancement of what I've just shown you. Flex cluster combines two types of nodes, the hub nodes and the flex nodes, the leaf nodes, I'm sorry. Hub nodes are traditional nodes tightly coupled via network and storage used for running I/O intensive workload. Basically the nodes that you know from 11.2 in 12c will be hub nodes. And if you install your cluster or upgrade, all your nodes will be hub nodes unless you say something, because you set it up as in 11.2. If, as a post-installation step, you enable flex cluster, you can enable leaf nodes. And why would you want to do that? Leaf nodes are slightly different. They run a lighter stack, they maintain their own failure and heartbeat setting. And that's what I'm saying. If you put this application Y or X that was running on the node before on a leaf node, and this leaf node would fail, nothing else happens in the cluster. The leaf node would just not be maintained anymore. If the node goes down, the application goes down, but it will be unaffected. The leaf nodes do not require direct storage access, so you could put them on a different type of node for not so heavy loaded applications. So there are a lot of ideas around it. Now, why would you actually want to do this? You skip this slide. Because you maintain a homogeneous way of managing your cluster, either by server pools, but more importantly, you preserve the way to create dependencies between your application and your database. You put the application in the same cluster as your database, you can set it up so that it starts and stops as required. I'll just dare to overtake 5 minutes and I'll take questions outside. I'll walk you right quick through installation and upgrade. With 12c, we have the idea to make installation upgrade much simpler. However, there are many small things we did with a big difference. For example, this flex cluster that I've just shown, you can choose to install it while you install the initial cluster, or you can do it post-step. But as an enhancement to what we have done in 11.2, now the 12c installer is meant to install every common constellation in which you can deploy rack. So if you use a flex cluster, use a standard cluster, you want to enable flex ASM as described, or you don't want to do this, you can choose this during the first installation. The second is that you do not have to log in on a per node basis anymore. As you know, the installer will provide you with a way to distribute the software. However, in the last steps of the grid infrastructure installation, you always had to run the root script, at least, if not the fix-up script, because you had to fix a little few things on your node. With 12c, you can provide the installer with either root or sudo privileges for it to run the root sh or the fix-up script in the end of the installation automatically. And that's basically it, except I don't have time for questions and answers as they are kind of waving at me over there. So thanks for your attention, and I'll wait for questions outside.